What is the Great Pacific Garbage Patch? Shocking facts revealed. The Great Pacific Garbage Patch is a massive collection of plastic and other debris floating in the North Pacific Ocean. Located between Hawaii and California, this environmental crisis has been widely discussed. There is still much to understand about its composition, its impact on marine life, and potential solutions to address it. Let's begin by looking at the composition and nature of the patch. The primary material of the Great Pacific Garbage Patch is plastic. This includes a variety of plastic items like bottles, bags, fishing nets, and smaller particles known as microplastics. They are tiny plastic fragments less than 5 millimeters in size. Why is the patch often described as a soup of debris rather than a solid mass of trash? It's referred to as a soup because the debris isn't collected in one large solid mass. Instead, it's spread out across a vast area of the ocean with pieces of varying sizes floating in different concentrations. What are the different sizes and types of plastic debris found in the patch, including microplastics? The debris in the patch ranges from large objects, like fishing nets, plastic bottles, and containers, to tiny microplastics created as larger plastic items break down over time due to the sun's UV rays and ocean currents. The primary ocean currents that create the patch are part of the North Pacific Gyre. This large system of rotating currents, including the California Current, North Equatorial Current, and Kuroshio Current, trap debris and pull it into a central area, forming the patch. Where exactly is the Great Pacific Garbage Patch located in the Pacific Ocean? The patch lies between 135 degrees west and 155 degrees west longitude and 35 degrees north and 42 degrees north latitude, approximately between Hawaii and California. It spans a vast area, roughly twice the size of Texas. How does the movement of ocean currents affect the size and distribution of debris within the patch? The gyre is a large system of circulating ocean currents, typically driven by the Earth's wind patterns and the rotation of the planet. Gyres are important because they move water around the ocean and can affect the distribution of heat, nutrients, and debris. Ocean currents continue to move debris, gradually concentrating it in the center of the gyre. This causes the patch to expand as debris is pushed and pulled across the region in uneven patterns. How do marine animals like birds and fish get impacted by the debris in the Great Pacific Garbage Patch? Marine animals such as fish, birds, and sea turtles often mistake plastic debris for food. When ingested, this plastic can cause blockages in their digestive systems, malnutrition, internal injuries, or death. Larger pieces of debris can also entangle animals, affecting their movement and survival. Plastics also leach toxic chemicals into the environment, further contaminating the animals' bodies and the ecosystems they depend on. Are there any documented cases of marine animals dying from plastic ingestion related to the garbage patch? Yes, there have been many documented cases where marine animals, like sea turtles, birds, and fish, have died from ingesting plastic. The debris can cause internal damage or poisoning due to the chemicals that plastic items release. The primary sources of plastic pollution need to be addressed to solve the problem. Let's explore how human activity contributes to the patch and what can be done. What are the primary sources of plastic pollution that contribute to the Great Pacific Garbage Patch? The main sources of pollution are discarded plastic items like bottles, bags, fishing nets, and microplastics from everyday products. Improper waste disposal, industrial runoff, and littering all play a major role in contributing to the patch. What are some individual actions people can take to reduce plastic pollution and the size of the garbage patch? Individuals can help by reducing their use of single-use plastics, recycling more effectively, and choosing reusable products. We can also support businesses and policies focused on reducing plastic waste and promoting sustainable alternatives. What are the current cleanup efforts aimed at addressing the Great Pacific Garbage Patch, and are they effective? Several initiatives are working toward cleanup, including the Ocean Cleanup Project, which uses large floating barriers to collect plastic debris. These efforts have shown promise, but challenges remain, especially in capturing the dispersed microplastics, which are harder to collect. In terms of scientific understanding, let's examine the challenges researchers face when studying the patch and the potential solutions. How difficult is it to accurately measure the size and total volume of debris in the Great Pacific Garbage Patch? Measuring the size and volume of debris in the patch is incredibly difficult due to its vast and dispersed nature. The patch isn't a solid mass, and the debris is spread across a large area, making accurate measurements a challenge. What are the latest scientific findings regarding the potential impacts of microplastics on marine ecosystems? Studies show that microplastics can accumulate in the tissues of marine organisms, affecting their health and reproductive abilities. Microplastics can enter the food chain, potentially impacting human health as well. Ongoing research aims to understand the full extent of these impacts. What are some ongoing research projects studying the Great Pacific Garbage Patch and potential solutions? Ongoing research includes the Ocean Cleanup Project, which is working on technology to collect ocean plastic. Scientists are also exploring biodegradable plastics and alternative materials to reduce plastic pollution. Additionally, studies are focusing on the ecological impacts of microplastics and finding ways to break down plastic more effectively. The Great Pacific Garbage Patch is a growing environmental challenge, but with continued research, innovation, and collective action, we can mitigate its damage. Understanding its composition, effects, and potential solutions is crucial for reducing ocean plastic pollution and protecting marine life. Let's all do our part to make a difference. Together, we can reduce plastic pollution and restore the health of our oceans.